are some shifts on the talks from the more, let's say, technical part that we began with Radovan, and a little bit of tech plus business with Boreal's talk, and I will go to the other extreme, so it's still good time to leave if you want, but I would strongly advise you against that. So I'm Pablo, and what I do is, well, I'm an applied mathematician and data science consultant, as in independent. I have a small one-man company, and I help companies build data science teams from scratch, provide training on data science and related technologies, but also create initial prototypes or working in problems that are more on the math side than on the machine learning side, still relying heavily on optimization, which is basically supervised learning, right? In a more general function space, and so on. I work mostly with small, privately owned, non-tech companies that do boring products, like plastics or manufacturing or lenses or like high-precision devices that are used in, I don't know, like 10 big companies in the world. I like working with those kind of companies. I do some work for big corporations, but I'm not very fond of them. I spend some time in corporate and would prefer not to spend that much, so that's why I mostly do training for them. Along my consulting, I teach in the Ukrainian Catholic University in Lviv. The motto of my talk is to talk about more the soft side, let's say, of machine learning models and how they are perceived and used in the business. And the news is that it's not very well. Large number of data science projects fail. According to some estimates by the research agency Gartner, it goes up to 85%, which is maybe not too new for people in IT, right? Because the fail rate for solved projects is around 60%, so it's still quite high, but almost 50% up. It's kind of worrying. And by fail, well, I mean, or for the purpose of this talk, fail means that it's not used. Yeah, so you did hire some people, like some super clever these guys to do some data science magic. You created some prototypes, and then no one uses them, right? So that means fail. So for me, a failure on a data science project is a model that is not used. Yeah? So as I said on the abstract, a model that is not used is just a useless model. Yeah? So there was no point to begin with that. And I'm curious, because I know this is a very diverse audience, if any of you has worked in this kind of failed projects. Yes. Yes. either version. Yeah. Okay. So few of you confessed, and the others, I don't know if they are on the 15% or if they are lying. We'll find out. I've been part of both failed and successful projects. Sometimes it has been my fault, sometimes it hasn't. And what I learned from all that is what I want to present today. There are some common patterns that, or rather anti-patterns, for data science projects. And why I think it's important is, well, on one hand, the impact that being on a failed data science project is kind of hard psychologically. Yeah, so you spend a lot of time, or at least it was my experience. I was in a very big project that failed, and I was traveling back and forth every week to France. And you spend all this time, all this energy, and then your project is crap. You know, the last day you're demoing it that no one's going to use it. I mean, everyone claps and stuff, but they're not going to use it. And this is very, very different when you do a project that you work in a data science project where people actually use it. I have recently completed a Shiny application for a client, and it's very simple. It's not like super complicated things like you maybe do. Most of you do maybe. But it really feels great when you know that the person is using your project. Like sometimes I log into my dashboard and I see that they're there, like, oh, they logged in yesterday. I'm so happy. They're using my stuff. And this is really, really important for, at least for selfish purposes of own mental health. If not, if you don't care too much about the company. Anyway, so the point is, well, can we avoid this huge, terrible failure rates in data science projects, and if so, how? So the answer is, of course, I think yes. And how is by four bullet points that I want to talk a little bit more about. So when you go to so the first thing is to have help the company find, if they don't have it already, the correct maturity level that they have. And by my maturity level, I mean the following. This is again something I borrowed from Gartner. And it's just a businessy chart plotting difficulty of a project against the value that it should bring. And there are four steps on this stair that are the maturity levels, let's say. So on one hand, we have the scripted analytics, which is just looking at having some data there and looking at what happened. No prediction, no machine learning whatsoever. On the second maturity stage, one asks about the past, but what made this past, this present be, right? So what happened in the past that brought us to this state, and that's a diagnostic maturity level. Then we have on the last two parts here the machine learning proper, right? So the big green square. So using data that has been collected by the company to predict what would happen in the future, and finally in let's say full reinforcement learning or full decision support scenarios, what can you do exactly with the outcomes of those predictions in a really actionable way? As an example of this, to make it like really clear, suppose you have an ice cream shop, or you're doing a project for an ice cream chain, yes, Angelato or something like that, and if they would be, this company would be on a descriptive, let's say, stage of their maturity, then they would be looking at answering questions like what were their sales last month. So really just describing basic stuff. On the next stage, so well, can we have a chart that shows you, that shows us the impact that the weather probably had on sales. So it's combining data from two sources. And this is already like super complicated for a lot of companies. And so, here we're talking maybe about 80 to 90% of the companies that are not tech-first companies. Then we have on the third, typical step on the third maturity level is, well, now I have historical data from both my sales and the weather, so it's two sources of data. Can we estimate the amount of supplies of like cones or milk or whatever you need to do ice cream? But still like in bulk, yeah. So I know that in this week, given that weather last year, I sold, I don't know, 1 million ice cream cones. So I need that much supplies to produce them. But still, in a bulk level and on a finer, concrete, actionable, really cool, data-driven business in action, you can identify like which shops require the amount of ingredients or supplies. Okay? So concretely on the shop level, right? The problem is that most companies want to jump from before here to there. And you would be surprised, but it's not unusual to find people who approach me, or maybe also some of you, and ask you about, yeah, I want to create this app that predicts Bitcoin or whatever. And you ask, like, okay, so tell me about the data you have. And like, what data you're talking about? It's just like deep learning, and it's like, no, this is not how anything works, right? And that makes a perfect recipe for the failure of a project. Yeah, so not understanding where you really are and what should be the next steps for you. Okay, clear? The other way to fail or to avoid failure of a data science project is a little bit trickier, and is to have a clear business problem to solve. So these are sometimes independent, sometimes correlated, and that's a trap that also tech companies tend to fall in sometimes. Or companies that want to be cool and throw money into data science, into AI, and whatnot. And there are here, I think it's really important to ask first, rather after any data science project you see, somewhat be cynical, be crude. I know that it's not very hard for Czech people to be so direct, so this is really important. What are the benefits of doing XYZ for the business? Yeah? So if there's no increase in revenue, if there's no decrease in cost, then what are you doing? There's no point on having this. And here we have two categories of failed projects. One is vanity data science, so that's, I would not name names, but some companies that like to have, we have this customer segmentation that is made with super embeddings of something, and the most neural network that is in the market, and we can plot it, and it looks very nice. And what are you going to do with this? Does this segmentation give you something? Does this give you actual information that can be translated in benefits? No, not always. So it's also a trap, and engaging in too many vanity data science projects is a recipe for disaster in the mid-long term, or sometimes short term. The other one is busy work. It's not because you can do something, it means that you should. In 2015, if you remember, everyone was having Hadoop, right? And it was a competition of who had the bigger data. And I was on a project, on this project that made me traumatized, I guess, in France. And we deployed, it was deployed for a private bank. They wanted to have, big data stack. So we deployed a Cloudera cluster with 3 nodes, storing some JSON files in HBase, and doing stuff in Hive. I don't remember exactly all the tools involved. And the workload that this 3 cluster operation was processing was 50 documents per day. Which is, you can do it by hand. It doesn't matter how incompetent you are. I mean, you cannot make it slower, right? So it takes as much time to wake up the cluster than to do it yourself. This is just busy work. It's just because you can have a cluster. It doesn't mean you should. And it also leads to people being frustrated and disappointed. The other one that is more common now, especially with a good marketing team at at Microsoft and Google and other deep learning infrastructure vendors is what I call the magic number. I was a couple of weeks ago in a telecommunications company in Austria, and they asked me if I could teach them how to create a score for how good the network is. Okay, so well, I'm not a network engineer myself, so can you explain me what does it mean good? Yeah, I mean like how good the network is, like good reaction time, good like low failure rate. What does good mean? I don't know. I mean, this is your job. No, you came here to teach us to get a score of the network. No, like that's not even a question, right? So have to sit with them and like try to explain them like, okay, let's put aside the magic number first, and I'll explain you what can supervised learning do, what can unsupervised learning do. You explain me what you do, and let's try to find a compromise between you getting happy enough to pay me and me giving you something close to what you think you want. Yeah, because it's not a magic number. It's not like you install scikit and then you get some metric that will give you a ranking of whatever, right? This is also a trap, and it's very easy to fall in any industry. Maybe too easy. So I have a template to try to get away from that, and is to just fill in the gaps there. So like this project should help someone to do something, either like scratch one or two of those, faster, cheaper, or with less errors. And this has an estimated either revenue or savings of that much. If you cannot fill this template, then maybe you shouldn't be doing what you're doing. If they are your employer, not your client, you should run. Because this is a sinking ship, probably, right? If you cannot convincingly fill in this template, then we have a problem most of the time. The other 2 points are really more concerned with the technical side. So having available data to solve the problem, that's sometimes too much to ask. Having the data on the appropriate granularity level. So if you want to predict, for example, demand on shops, like you have Tesco and you want to predict how much are you going to sell of a certain item on this shop, then you should have data at the shop level, right? You cannot have data at the city level or at the district level and expect to have individual predictions. This is just not going to make it. There should be some identifier within the process. So if you have, you want, like one common use case that always fails is to try to tie marketing spend to sales, but then you don't have a key to join them, right? So you have some transactions with some transaction ID, you have some purchases, you have in Google Analytics, but then you cannot join them, yeah? So, okay, it's there before the beginning. Sometimes you can, depends what you have in place. But most of the time, it's hard. The other is to have support from the IT infrastructure within the company. If you cannot install the tools you want, then you cannot work as a data scientist. But also, there are some funny, absurd situations where you have to steal data from other teams because they cannot talk to each other for political reasons. So I've had to write scrapers to take the data from another team in an internal company page. It's not ideal, right? So it increases, the time that the project takes, and it's just a phone call. So that's bad. Yes. Sometimes you also get blacklisted internally, so it's not good. So these are points that I've found common in all projects I've been that have failed somehow. Consulting companies will not tell you that, will never tell you, this is something I cannot do. They will always tell you, yes, we can do it. It will cost that much. So even if you land, whenever you land in one of these, the project can still be dragging forever and not produce any outcome. So it's important to identify if you are on one of these traps and try to do something about it. I think it's the responsibility of everyone who is capable of understanding what the blocks are. It's not a responsibility of the manager, but it's also a responsibility of the individual contributors and data scientists and others. Projects, anyway, do not happen in isolation, and as a second part of my talk, I want to also share a few points of common traits I found in successful data science teams. I move across a lot, so I know a lot of, I've seen a lot of things in a lot of countries, and it's interesting to see the dynamic, but small regional differences aside, it's always 5 traits that I found in cool data science teams that do not belong to that 85%, but rather go on the 15% successful projects. And one is, oh, I'm sorry, you cannot read, but I will read it for you. So data beats algorithms. Yeah, so even I can't read. Attention to detail beats engineering wizardry. Yeah? So that's something I found, and I will be a little bit sexist this time, but sorry about that. This is something I found that girls are much better at than men. Girls have a very good attention to detail for data, for detecting data quality issues, for being careful on what things are being joined than guys. Guys want to build end-to-end pipelines and calculate everything fast. Yeah? And this is not always what is needed. Okay, so again, this is tied to my experience and the type of clients I work with, which is not on the tech sector typically. Data is more important than algorithms in lots of cases. If some of you remember the times when Kaggle was still fun before H2O came to with these wonderful ensemble models, and now everyone can win with 3 clicks. Feature engineering was the key. So you could see that models with logistic regression and a lot of data polishing and carefully looking at examples were the models that won at least on the top 5 places. Now it's just XGBoost away. Yeah, so that's a problem. So if data beats engineering, I would say that communication is even more important than data. It's important for data scientists, regardless of the level of seniority, to be able to talk to other people within the IT or within the analytics department, and talk to business and domain experts in their terms. I'm working right now with someone from storm water modeling department, and they have very funny names for the R² metrics and all the regression metrics. They have their own domain heroes after which these metrics are named. So you have to learn to talk in that language. They do some funny normalizations so that they multiply the metric that you know from scikit by some magic number, and that's a thing for them. So okay, you have to learn to talk about it. Lovely geniuses have really no place in the modern marketplace, especially not non-tech companies. And this is so. This is also connected with. So being an isolated genius is not going to do it, but being too smart is also not going to do it. And this is maybe the other extreme of the spectrum. So you are too smart and you don't hesitate to tell everyone about it. Yeah, so superstar data scientists become very often the single point of failure, and there are flight risk because by their nature of feeling super smart, they're always looking for the best place to go after. Successful data science teams have no divas, yeah? So that's important. Another thing is instant experts are also usually not there. Someone who is trying to sell you a boot camp or a course or something is not necessarily a good person. Courses are complements, but not substitutes of a technical degree. Yeah, so you cannot. This is just like a horrible lie that democratizing data science, blah blah blah. Like no, this is dangerous. There still needs to be a serious understanding behind. Yeah? So no, well, boot camp will make you a data scientist. I'm for sure, unless you have a degree. And it's very rare to find bootcamp people in good teams. And the last one is, well, this is something that was mentioned already somewhat in the other talks. They actually have two phases. Okay, so I maybe was to course and through delivery and deployment into one, but one way that some good data science teams work is to have this clear division between when are we playing around with stuff and when we are actually building the stuff that is going to be used somewhere, right? So there has to be a point when you say, okay, stop, this is it. No more feature engineering, no more trying different pipelines. Now we just focus on the delivery aspect. Yeah? So like writing good documentation, having repeatable code, having some audit track for the models, which is important in some regulated industries and so on. But it has to be really a good distinction. Now this is something that academics do particularly bad, because this is not how academia works in a way. So there's a back and forth between discovery and delivery, and discovery takes usually time, but it's dense within the delivery time, so it extends everything forever, and you end up with no outcome. Yeah? So this is something to be wary about. So as a matter of conclusion, and I'm just on time, well, some positive message. Not everything has to be failures. I mean, I shared with you my ideas of how we should avoid those failures, and what has more or less successfully worked for me. There are lots of machine learning use cases in industry. There are lots of also boring non-tech companies that are getting advantage of those. If you want to learn more about it, just keep coming to machine learning meetups. There's always someone saying something interesting. And the last part, conclusion of my conclusion is that really remind you that it is maybe this stuff sounds like too businessy or whatever. I don't know what you think about this. You're badly regretting not escaping. But I think it is part of our job to really help those that are not experts in machine learning to figure out what they really need. Yeah, so there's, and I think it also extends to other areas of software development. It is part of our job to help the people to understand, to better express their needs, because what they tell you they want is not what they want. It's not what they need 95% of the time. If you want to work in a line of job where you don't have to care about this, where the client always knows what they want, then there's a right on the corner there's a McDonald's. Yeah, so clients there always know what they want, and will tell you exactly. So that's the occupational hazard that comes with inflated salaries. And okay, that's I think my message for tonight, so feel free to get in touch. And, thank you. Questions?
I have one. So you said that since H2O provides various tools and there are people instantly winning table competitions, what's your opinion on why this is not true in the real world? Why like anyone cannot just come, take data and win?
That's also not necessarily true, and it really depends on what kind of data we're talking about. You can just throw data at some algorithm. You have, for example, data that is generated consistently on the same way. If you have like video surveillance, maybe you can just throw video, put it on H2O, and then you don't care anymore. If you have transactional data that something changes on the business, then maybe not. No? Because the transactions are tied to some other processes that fail, that have changes. So maybe it depends, I would say. As I said, I think data is the most important part anyway. So you have to be sure that that this is correct. Another thing is that well, algorithms are not really like part of the IP anymore. It is the data which is what matters. So, like, 5 years ago, there were no these tools, or in a previous state, and now they are free for everyone, or yeah, soon to be the newest ones.
Okay, so you mentioned so many projects or mistakes, so it's not working. And I would like to ask, maybe you can say something like from your experience, which project did work and the customers were really happy and there was real business value there, like, I don't know, cost savings or infrastructure or these four, as you showed us, this kind of graph.
Yeah, well, successful stories don't sell well, so I had to go for the tragic side. No, that for example, now for the we have a project on for modeling this flow of stormwater. That project is still ongoing and it's still early on, but we have thanks to proper, like sane data modeling practices and using, for example, Bayesian optimization, you can. So that the objective of the problem is to calibrate the simulations from an industrial simulator against the observations and experiments. Right? So this is a very tedious job. So you typically hire someone super junior and make him play a lot with the simulator. But there are better ways to do that. Yeah. So. The simulation takes around 1-2 minutes to run, so you cannot just throw it and leave it because it will take some time. So instead and furthermore you want to have some error estimates or sensitivity estimates of the parameters. So you can reduce all this manual work with a little bit of Bayesian optimization, for example. Yeah, that has. Like the benefits are hard to calculate in numbers at this point, but it's multiply the unit cost times the numbers of hours.
I have a question from maybe somehow unrelated field, but leveraging your experience. How would you deal as a supplier of a service, some external consultants, how would you deal with a company, for example, the ice cream producer, that would want to create internal teams for predicting weather? So sort of very simple business case, selling ice cream, you feel that weather prediction may help you predict some production or something like that, and such a company would like to do weather forecasting themselves.
That's a bad idea, no? In so many ways. I think you should not reinvent the wheel. Yeah? So if there's something that you can buy it, then just buy it. And I'm sure there are many companies specializing in predicting weather better than your internal team. Yeah? Unless you have some proprietary data, but usually not. For example, for maybe for wouldn't make sense to have your own automatic translator from Czech to English, right? Like, there's an API. How specialized you need to be? Maybe not that much.
Is there any important factor of to have some buy-in who really wants the project to work? I mean, somebody who really take cares?
Yeah.
I was surprised that I didn't catch it either on bad or good side of what you mentioned.
Yeah, I think that was one of the hidden assumptions that didn't made it to my head, but not to the slides. Yes, you need to have someone that really wants the project and would sponsor it for you. Like sponsor doesn't mean that they will directly pay it, but that they will influence the people around. Otherwise, it's really hard. I've been in projects that had like a sponsor on a very high level. Yes, so it was like the CEO of not even the country. It was even from the group. Yeah, so the motherboard. And that's really terrible because like everyone. So the CEO, the country CEO hates it. The IT guys hate it because you are doing something in the little field, so you shouldn't touch it. And then it's very hard to work. So that's also really important. Thanks for reminding me.
So I have a question. You mentioned that the data mining, the consequences of good data mining project is cost cutting or productivity increase or labor heart of the labor decrease. It means, or my question is, if you have if you know some successful project, if any government-run organization, because according to my opinion, this is against the státní správě, how to tell, government-run organization, if some data mining project exists. The question.
Well, that's a good question. I don't have a lot of experience with government projects, so I cannot answer. But let me think if. No, really, sorry, I don't.
Maybe because it is against the idea of the organization, right?
I mean, it's there are victimless crimes, right? So, and it's the same in big companies. Right? So if a project fails, then it kind of gets absorbed, and everyone knows that there's like as long as you don't cross some imaginary threshold of failures, then it's okay. So if there are no direct responsibles, you can go along with your life. But there are other consequences, no? Rather than like for the people who participate on the project themselves, that maybe are also important.
Okay, so thank you, Pablo, for this presentation.